Now that you've seen equilibrium for acids and bases, let me show you what equilibrium looks like for solubility problem. Okay, so for solubility, we're going to deal with things that are technically precipitates, okay, or what you've learned about as a precipitate before, but it's not really a precipitate, okay? The point is that even though things seem to not completely dissolve in water, they can dissolve a little bit in water. And so what we're going to do is figure out exactly how much of it actually does dissolve in water or dissociate. Okay, and so we're going to use this expression KSP. The SP stands for solubility product, which is related to the concentrations or the amounts of the ions that are present in an equilibrium reaction. Okay, so let me give you an example. If you remember the solubility rules from before, something like silver chloride is a solid. It's considered to be a precipitate, right? It's one of those exceptions that does not dissolve in water. Okay, now what I'm going to tell you is, well, it does dissociate just a very small amount. Okay, and so I can think of an equilibrium reaction where the AgCl breaks apart a little bit into silver ions and chloride ions. So the equilibrium expression is going to look a little bit like this. Okay, AgCl, solid, is going to be in equilibrium with Ag plus ions and Cl minus ions. And the point is that because these are ions, these are going to be in solution. So AQ and AQ for aqueous. And so my equilibrium constant, my KSP, is going to be simply concentrations of the products, right? So concentration of Ag plus times the concentration of Cl minus. Notice that all the coefficients here happen to be 1, so all the exponents happen to be 1, divided by the concentrations of the reactants. But in this case, the reactants is a pure solid, so I don't have anything to write, and it's just going to be 1. This is why it's called solubility product. Okay, it only really includes the products in there. So KSP is going to be the concentration of Ag plus times concentration of Cl minus. Okay, if I had something like, I don't know, Hg2Cl2, or maybe PbI2 is a better example even. Okay, let's look at that one. If this dissociates into lead ions and 2 iodide ions, my KSP here is going to be the concentration of lead ions times concentration of iodide squared. And the 2 there is because there's a coefficient of 2 in front of the I minus. So just to give you some examples of KSP values, here's a table that isn't complete, but just kind of highlight some typical values that you might come across. Okay, so you can see here on the left are the names of different compounds, what their formulas are, and what the KSPs are. And the point here is that you shouldn't memorize these numbers, but most of these values are very small, right? These are for solids that don't really dissolve very well, so they tend to form precipitates pretty readily. Okay, in terms of exponents, okay, you see things like 10 to the negative 9, 10 to the negative 10, 10 to the negative 30th even, something like that. Okay, so these are very tiny numbers, but the point is that they're not 0, so there will be some concentrations of ions present in the solution.